So now in this video, we're going to take the circuit from the last video, but with a slight modification. We used a variable resistor in the last video. This video, we're going to use a light dependent resistor. What this circuit does, it's an astable 555 timer. As the output changes from high and low, the passive buzzer makes clicking noises when things are slow enough. I can slow it down even more by covering the light dependent resistor, and even more by turning off the lamp. The overhead light is very energy saving. But in any case, we can also speed it up. So the lamp right now is at its brightest setting. I got the side light of this flashlight because it's better for these circuits than the main light. And there you can see we can make change in noise with the light. So in any case, that's about all there is to it. As I said before, we just took the circuit from the last video, swapped out a variable resistor for a light dependent resistor. I'm doing my short video series right now. I'm keeping these as short as possible. So a lot of these circuits will just be slight modifications, but you can see they make a different circuit. And that's what electronics is. It's a lot of basic stuff, but you combine it in different ways. You get different interesting circuits for the most part. So just as a reminder, the passive buzzer, it needs a changing voltage to basically get clicks, but you get them fast enough it sounds like a buzz. I think if you go fast enough, you don't need a coupling capacitor. I could be wrong, but when I wired this up without a coupling capacitor, when the output was high, I got high current, more than 150 milliamps of current. That was the maximum I set at my power supply, so I don't accidentally fry anything. The 555 timer usually has a limit of 200 milliamps of current, either sinking or sourcing. So with the coupling capacitor, when the output is high, it charges. You get a click, and it doesn't seem to change the sound of the click from what I did from limited testing. But once the capacitor charges, it stops passing current. And then when it goes low, the capacitor discharges, you get another click. And again, once the capacitor is discharged, there's no more current flow. When you don't have a capacitor, if it goes to ground, then you just cut power from the buzzer. It clicks again. I think the click sounds the same. But in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.